Okay, good morning, Professor David J. De Los Reyes. Okay, the topic on my next session will be imaginary numbers or complex numbers. Imaginary is synonymous to complex number. Okay, let's proceed. Imaginary number or imaginary numbers. In mathematics, imaginary number is designated by letter I, and the other equivalent of this is actually represented by J. J. I is used in mathematics, and this J here is used in AC circuit calculations that involves complex numbers. So the importance of imaginary numbers is just in the so-called computation of the square root of a negative number, like the square root of -4. Because we cannot take the square root of -4 if we will not introduce the value I square. Because -4 can be written as the square root of -1 times 4. And in mathematics, this one here is designated I square, and that is imaginary. So in here, if we got a square root of -4, it can be written as the square root of -1 times 4. And we will replace this I square, no, -1 by I square. So this will become the square root of I square times 2 square. Or what will come out will be plus or minus 2i. So the only significance of imaginary numbers in mathematics is for us to take the square root of a negative number. Because without taking or without presenting the -1 to be I square, we could not take the square root of a negative number. So the importance of imaginary number in mathematics is to simplify. Okay? But the other equivalent of this, okay, and which it is very useful to mankind, is actually we represent this I by a letter J, and this letter J is actually a complex number. Because a complex number contains the real part plus J imaginary part. Okay? It contains a real part and imaginary part, and for us to notice the imaginary part from the real part, if we try to write the so-called imaginary part, we precede this one by letter J. Okay? This is letter J. Right? So actually the most important thing on the imaginary number is that it is equivalent to letter J, but actually in reality it is very useful to mankind because in the calculation of alternating current circuits we use the letter J because the calculations involves a real part and imaginary part. Unlike in the so-called direct current circuit, we are only calculating real parts over there. 3. There is no such thing as a plus G something on DC circuit. Like if the resistance in a DC circuit, resistance is just represented by 3, in which 3 is a real number. But under AC circuit, the total opposition to the current is now represented by a real part plus J, the so-called imaginary part, XL or X sub C. there is a G sign over here, and this G sign is J, and that is actually, it came from letter I. So the one we are solving on the shorts videos, the letter I, as for me, it got no significance. The only significance for this letter I is its equivalent in J, and this J here is used in the so-called calculation of alternating current circuit. Or I will give you an example of a complex number that involves a J, which emanates from this I here. So, like those they are solving J to the J, it has no significance. But an AC circuit, okay, that J has a significance. Because without knowing that J, we could not calculate impedances under AC circuit. Or I will give you an example problem of a complex number in AC circuit that involves the J. Okay, I will try to erase this one so it looks good. And so with this one, the importance of this letter G now, which emanates from this letter I in complex circuit, is in the representation of impedances. Impedance is the total opposition of alternating current. We designate that as Z, as impedance. So I place it here, Z1, Z2, Z3, and Z4 are all impedances. Impedance is for AC circuit, resistance is for DC circuit. Impedance is a complex number which involves the letter J. Okay? So, for one case of an impedance, if I will place Z1 to be equal to 3 plus G0, meaning the resistance is 3 ohms and the inductance is 0, it is 0. Another example, I could write the impedance to be 4 plus G3. The meaning of this, the resistance is 4 ohms and the inductive reactance is 3. If this is plus, this should be XL, inductive reactance, XL, right? So as you notice it, Z1 and Z2 involves the J, and this J here emanates from this, and this J is actually equivalent to I in mathematics. Okay? Another example of impedance which involves the J is actually 0 minus J4. The resistance here is actually 0, and then the reactance is actually 4, but this is negative sign, so this should be an X of C. Okay, so we now know the importance of this J here in the presentation of impedances in AC circuit. Okay, another example, it will be 0 plus J5. The resistance here is also 0, but the reactance is 5. It is plus 5. So if this is plus, this should be an XL. So for all the impedances representation, okay, the G sign is actually present. This is plus G0, this is plus G3, this is minus G4, this is plus G5. And this G here emanates from this, and actually it came from this letter I over here. For me, the problem, what's the equivalent of I to the I don't mind about that. What I mind is actually the real application of this J and mankind. And we use this in the calculation of alternating current, okay, circuits. Because if we do not know how to call this simplify impedances, which are in parallel and series, okay, and this involves complex numbers, okay, we do not have this, what I call this, alternating current utility companies, because the competition for these utility companies involves the J sign. So the importance of this imaginary thing I, which is equivalent to this letter J, is actually in the computation of the so-called alternating current circuits for utility lines. Okay, good morning from Los Angeles.